Sir Isaac Newton was a real superstar in the world of science. His contributions were so profound that they still resonate today. Born in England way back in 1643, he totally changed how we think about the universe. His early life was marked by curiosity and a relentless pursuit of knowledge. This super smart guy helped us figure out how the world around us works. Newton's ideas were game changers. He wasn't just a thinker, he was a doer, constantly experimenting and challenging existing beliefs. They became the foundation for a lot of modern science. His work laid the groundwork for countless scientific advancements that followed. Before Newton came along, people didn't really get how things moved or why stuff fell down. The concept of gravity was a mystery. Newton's work explained all of that and more. He introduced the laws of motion and universal gravitation, which provided a new framework for understanding the physical world. He came up with groundbreaking theories about motion and gravity. The famous story of the apple falling from the tree is just one example of his genius at work. And guess what? Even hundreds of years later, scientists today still rely on these theories. His principles are applied in everything from space exploration to everyday technology. But Newton's impact wasn't just about physics. He also made significant contributions to mathematics, particularly in the development of calculus. His work influenced math, how we study space, and even how we build things. Engineers and architects still use principles derived from his theories. His ideas sparked a huge interest in science and continue to inspire new scientists and thinkers today. Newton's legacy is a testament to the power of human curiosity and intellect. One of Newton's most important discoveries was his 3 laws of motion. These laws form the foundation of classical mechanics and have been instrumental in our understanding of how the physical world operates. They are not just abstract concepts, but are principles that we can observe in our everyday lives. These laws explain how objects move and how forces affect them. They help us predict the behavior of objects in motion and at rest, making them crucial for everything from engineering to space travel. The first law, called the law of inertia, says that if something is still, it'll stay still. This means that an object at rest will remain at rest unless acted upon by an external force. And if something is moving, it'll keep moving at the same speed and in the same direction unless something else pushes or pulls on it. This is why a car will continue to move forward on a highway until the driver applies the brakes or another force like friction slows it down. Imagine a soccer ball just sitting on the field. It won't go anywhere until someone kicks it. This is a perfect example of the first law of motion in action. It won't go anywhere until someone kicks it. The force of the kick changes the ball's state from rest to motion. That kick is a force that changes how the ball moves. The ball will continue to move in the direction of the kick until other forces like gravity and friction act upon it. Now picture a bicycle rolling down a hill. It's going to keep going faster and faster because of gravity pulling it down. This is another example of how forces affect motion. It's going to keep going faster and faster because of gravity pulling it down. The force of gravity accelerates the bicycle, increasing its speed as it descends. The second law tells us how force, mass, and acceleration are all connected. It states that the force acting on an object is equal to the mass of that object times its acceleration. It says that the force you need to move something is equal to how heavy it is times how fast it's speeding up. This means that heavier objects require more force to accelerate. This means you need a bigger push to move something heavy compared to something light if you want them to go the same speed. For instance, pushing a heavy object like a barbell requires more effort than pushing a lighter object. Think about pushing a shopping cart. An empty cart is easy to push and get going fast. You can maneuver it with minimal effort. An empty cart is easy to push and get going fast. But a cart full of groceries needs a lot more force to get it moving at the same speed. But a cart full of groceries needs a lot more force to get it moving at the same speed. This illustrates the second law of motion, where the force required is proportional to the mass of the object. The third law says that for every action, there's an equal and opposite reaction. This means that forces always come in pairs. When you jump on a trampoline, you push down on it. The trampoline then pushes back up with the same force, making you bounce up in the air. The trampoline then pushes back up with the same force, making you bounce up in the air. This is a clear demonstration of the third law of motion, where the action of pushing down results in the reaction of being pushed up. Newton's law of universal gravitation is another super important idea in physics. This groundbreaking concept was introduced by Sir Isaac Newton in the 17th century and has since become a cornerstone of our understanding of the universe. This law explains why things fall to the ground and why planets go around the sun. It's the reason an apple falls from a tree and why the moon orbits the Earth. Essentially, it governs the motion of objects both on Earth and in space. Newton said that everything in the universe pulls on everything else with an invisible force called gravity. This force acts at a distance, meaning objects don't need to be in contact to exert gravitational pull on each other. How strong this pull is depends on how heavy the objects are and how far apart they are. The greater the mass of the objects, the stronger the gravitational force between them. Conversely, the farther apart they are, the weaker the force. The heavier something is, the stronger its gravity. For example, a boulder has more gravitational pull than a pebble, and a skyscraper exerts more gravitational force than a small house. The closer two things are, the stronger the gravity between them. This is why the gravitational pull between two magnets increases as they get closer to each other. That's why we feel Earth's gravity so much more than the moons or the stars. Earth's massive size and our proximity to it make its gravitational pull much stronger than that of distant celestial bodies. Earth is way bigger than them, and we're much closer to it. This size and distance relationship is crucial in understanding why we stay grounded on Earth and not float away into space. Newton's law of gravitation explained why the moon goes around Earth. The moon is kept in its orbit by the gravitational pull of the Earth, creating a delicate balance that keeps it from drifting away. It also explained why Earth and the other planets go around the sun. The sun's massive gravitational pull keeps the planets in their orbits, maintaining the structure of our solar system. Even though these theories were discovered ages ago, they're not just some abstract ideas. We see them in action every single day. When you drive a car, how the car moves follows Newton's laws. When you throw a ball, gravity decides where it's going to land. Even just sitting in a chair depends on Newton's laws. Your weight pushing down on the chair is met by the chair pushing back up with the same force, so you don't fall through. Engineers use Newton's laws to design bridges, buildings, and airplanes. Scientists use his theories to study how planets, stars, and galaxies move. Newton's work is fundamental to understanding how the universe behaves. Newton's theories provided a strong base for modern physics. Scientists that came after him built upon his work, expanding our understanding of the universe even further. For example, Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. Einstein's work improved and expanded upon Newton's law of gravitation. However, it didn't prove it wrong. Newton's laws are still incredibly accurate in most everyday situations. Newton's work continues to inspire new discoveries. Scientists today are using his theories to explore the universe in new ways. From understanding how black holes work to developing new technologies, Newton's legacy lives on. Newton's impact goes way beyond our planet. His theories helped us understand how things move in space. They allowed us to predict the existence of planets before we even saw them. Newton's work made space exploration possible. It allowed us to launch satellites, land on the moon, and send probes to faraway planets. Even today, when planning space missions, scientists and engineers rely on Newton's laws of motion and gravity. These laws help us navigate spacecraft through the solar system and beyond. Sir Isaac Newton left behind a legacy of groundbreaking discoveries. His work transformed our understanding of the universe and our place within it. His theories continue to be the bedrock of modern physics. They are essential tools for scientists, engineers, and anyone seeking to understand the world around us. Newton's story is a testament to the power of human curiosity and the enduring impact of scientific inquiry. His work reminds us that the pursuit of knowledge can lead to profound and lasting changes in our understanding of the universe. Sir Isaac Newton's contributions to science are vast and continue to impact us today. We encounter his work in countless aspects of our lives, from the technology we use to the way we understand the universe. I encourage you to delve deeper into Newton's theories and discover the wonders he uncovered. Read about his life, explore the principles he developed, and consider how his work continues to shape our world. The journey of scientific discovery continues, and it's up to each of us to follow in the footsteps of giants like Sir Isaac Newton.